Please like, share, and subscribe.
So determining the first root of f by first principle, and this is a standard form of starting out. Where in most cases you'll be given f of x, and you then have to manipulate that same function to bring about this part of the function, which is simply adding h to x. So initially we know that f of x equals 3x squared. So to manipulate that, we just add h to x and simplify. So instead of x squared, I'm going to have x plus h squared. And I just continue that until it's simplified. I come back here and I maintain everything till I get to my solution. Now you do not remove this part. The limit is h tends to 0. All we do is we substitute. In place of f of x plus h, we insert the one that we just manipulated, or we just worked out, which is 3x squared plus 6xh plus 3x squared. And this we subtract the original or the initial, the one we were given, which is 3x squared. We divide all of that by h. And again, just maintain this. Now you'll see in most cases, your given function and the first few parts of the one you worked out will usually cancel out. So of course 3x squared minus 3x squared. See, that leaves us with just 6xh plus 3x squared. And all of this is divisible by h. And we keep working it out, just like that. And of course you'll see here we have a common factor of h. So we factor it out and that leaves us with 3h plus 6x. And all of this is divided by h. Now of course, these two guys will kind of give us a quotient of 1. That's going to leave us with the limits to h tends to 0. 6x plus 3h. So now the last step is when you write your last part, you do not include what we've been writing out here. You do not include the limit. What you do rather is you substitute h 0. So in the place of h you put 0 when you get to the most simplified part of the whole method. So you got 6x. There's nothing else to do because you could factor out 3, but that's not really going to change anything. So you might as well just go ahead and substitute. Where you see h you put 0. So the first derivative becomes 6x plus 0, meaning your final solution is that the first derivative of a function of f is 6x. And what this really indicates is an equation of a gradient, basically, throughout the function f of x. That's all it indicates. It's an equation of the gradient slash slope. What is the equation of g? Add this value here, and then we should find the value of a. Well, this is a no-brainer really, because this part of the function will actually help us figure out what it is that we want, and maybe then the second part thereof. So what I mean by that is the fact that we need to understand that the equation that's given to us is more in square root form. So let's assume that this is the function, right? If this is the function, then what happens for us to get 2? Right? What happens for us to get 2? Of course, we must have g of 4, because square root of 4 is 2. You see that? So what does that tell us? Clearly, the equation that we're looking for is indeed square root x. And the number a, in this case, will be what? Will be 4. We are looking for dy dx if y is square root x cubed minus 5 out of x cubed. Of course, the first thing is for us to simplify the given equation. And the way to do that is to have everything in exponential form. So everything must be in exponential form. So y equals, that could be changed to x to the power 3 over 2. And that could be changed to minus 5x power minus 3. Basically laws of exponents. Now we can work with this. So to rephrase the question, what is dy of x power 3 over 2 minus 5x power minus 3 all over d of x? This is what you call the shorthand method, and I like to use the, I guess we could call it the formula. Whenever you derive, I use the, form k and x power n minus 1, where k is the coefficient, n is the exponent, and I guess x is the variable. So the solution to this is then k for this particular function is 1, the coefficient is 1, the exponent is a fraction 3 over 2, and the x, of course, variable is x, and the exponent is still 3 over 2, and according to the formula I'm supposed to subtract 1. Now this term is my first term, and what I do is I subtract the other part. So this time around, my coefficient becomes 5, my exponent is minus 3, x, exponent minus 3 minus 1, and this then becomes 3 over 2 x power 1 over 2 minus bracket minus 15 x to the power minus 4. Let me just continue on this side. So the solution becomes 3 over 2 x power half plus 15 x power minus 4. Now if you want, you could leave it this way, but I like to take things a little further. And so what I do rather is I have everything, or I will have everything in either root form, and if I have a negative exponent, I'll try my best to change that to a positive exponent. And so this becomes 3 over 2 square root x plus 15, and the only way to make that a positive exponent is if I have it as a denominator, so that is x to the power 4. Now, as I said before, you could leave it here if you want to. This is enough of a solution, but I just did the extra work there. So firstly, we are told the g of x is minus 8x plus 20. But again, I'm told that I have a function x cubed plus ax squared plus bx plus 18. I'm told that this function g of x is actually a tangent, and that these two functions actually intersect, or this is rather the tangent of this function at x equals 1. So of course, what we're looking for will be the values a and b. And how do we do that? With the information that's given to us. Pretty easy. So first and foremost, what I want to do is I want to find the actual coordinates. Okay, so thankfully I already have the function that describes tangent, and I already have the x value. So what I do is I simply substitute the x value into the function to get my y value. If I substitute 1 into this function, I'm going to have 12, because minus 8 plus 20 is 12. Now, at least I know that the point of contact is at 1 and 12. What I do is I go ahead and I substitute these coordinates into the function. So I know that f at 1 requires me to, of course, substitute 1 where I see x. So I'm going to have 1 cubed plus a into 1 squared plus b into 1 plus 18. So f of 1 is 1 plus a plus b plus 18, sorry. And that is a plus b plus 19. Now the other part is that the y value when x is 1 is also known to be 12. So I can just equate these two and see what I get. So a plus b plus 19 equals 12. And I guess we could call that equation 1. Now what I do next is I use the gradient to my advantage. So I already know the gradient of this function. So what I do is I'm going to derive this given function here to get my actual equation. So the gradient of the function following the formula k n x power n minus 1, this whole thing becomes 3x squared plus 2ax plus b. And what I do next, like I mentioned, the gradient there is given to be as minus 8. As we know, the equation of a straight line takes on the form y equals mx plus c, where m is the gradient. So from this equation, I can tell that the gradient is minus 8. So we know that the point at which these two graphs touch actually equates everything. So it equates the gradient and equates the actual coordinates. So we had already equated the coordinates to get to this equation. So what we do next is we equate the gradient to get to the next thing. So when I substitute into this, I will have something of this nature. So I see x, I put 1. So that becomes 3 plus 2a plus b. Like I mentioned before, the gradient at that point is the one that we have there, which is minus 8. So I go ahead and equate these two. So 3 plus 2a plus b equals minus 8. And so I guess from this equation I can make b subject to the formula. So let's just say b equals minus 8 minus 3 minus 2a. And this is minus 11 minus 2a. So what I do next is I could just simply equate the two there. So I could just say substitute b into, say, equation 1. So I will have something of that nature. Instead of b, I'll just put in that whole function there. Plus 19 equals 12. So just work that out to find a. That's 12. And of course, this is actually minus a plus 8 equals 12. Let's just, vice versa. I'm going to bring a on the right and left on the left, 12 on the left. So I'm going to have minus 12 plus 8 equals a. So a is actually minus 4. And of course from this, I can just substitute a into b. Which is this one right here. So b becomes minus 11 minus 2, and a is just negative 4. And this can be simplified to minus 11 plus 8, which is simply minus 3. I'm looking for the stationary point, the x coordinates of the stationary points. So the stationary point is what we call critical points. So this is basically like your minimum or max points of the function, basically. Now, what we know is that in most cases, because the first derivative happens to resemble a parabolic function, this is probably derived from a cubic function. So this is the equation that describes the gradient throughout a cubic function. So what we do know is the gradient at critical points, or stationary points as they put it, the gradient at those points will be 0, right? So what we do next is, of course, equate that first derivative to 0, and we just work out x from there. So 3x squared plus 8x minus 3 equals 0. Now I know that some people actually have difficulty with this, factorization method, but if you have a problem with that, you should work on it. However, if you really cannot get around it, then I'd best advise you use the quadratic formula. But we are going to factorize. So this will be 3x, that's my first coordinate, 1, first factor. I'm going to have x again at the other end, and 3 on the other end. Now the reason I do this is so that I can allocate or accommodate the larger factor b, which is 8, because I already see from this form that if I have to multiply 3 times 3, I'm going to get a 9, and from the 9 I can subtract a 1 to get to 8. So this is 3x minus 1, and I equate that to 0, or x plus 3 equal to 0 as well. So from this I can just rearrange it to x being 1/3 or x being -3, and those will be my critical or stationary values or points. When we say that a function or an equation represents the concave down part of a function, well, that's simply put, you could just derive the function a second time, also known as the second derivative. And for us to have concave down, the second derivative must be actually a negative. So the way to express that is, you would say second derivative is less than 0. So I already know the first derivative, which was 3x squared plus 8x minus 3. If I derive this further, I will have 6x plus 8. I actually realized that I'm missing a variable x there, my bad. So of course I'm going to have this part expressed in that manner. So 6x plus 8 is less than 0, and I'm obviously going to find x from this. Divide both sides by a positive 6, and x is actually less than minus 8 out of 6, which could be further expressed as x being less than minus 4 times 2 multiplied by 3 times 2. Of course, as you can see, these two will cancel out, meaning x is actually less than minus 4 divided by 3. So it is within this interval that my function is concave down. How do you know that a function is increasing or decreasing? Well, for a function to be increasing, the gradient has got to be positive. So of course the gradient is actually the first derivative, which is given to me as 3x squared plus 8x minus 3. So I put this in inequality form. First derivative is greater than 0, and I just substitute accordingly. So this is 3x squared plus 8x minus 3, and that's going to be greater than 0. And like before, I can factorize this, x and 3 plus and minus. So 3x minus 1 is greater than 0, or x plus 3 is greater than 0, and this is simply 3x is greater than 1, or x is greater than minus 3. I just change this around. That's of course x being greater than 1 out of 3. So clearly I got two solutions here. One of them has got to change the inequality sign. A lot of people didn't quite agree with me. However, I think you can go on and revisit this during your self-study period. And I actually got to find out that in most cases, when I'm dealing with inequalities, actually I've come to understand that the lesser factor tends to change inequality. So the lesser factor changes. This is the discovery I came across after multiple lectures because most textbooks and some teachers will actually require you to draw a function and do the horizontal line test, and I found that to be very tedious. So that's the conclusion I came to after multiple attempts of learning the topic on inequalities. So to conclude, it is to say that x would be either greater than 1 over 3, but it will have to be less than minus 3 because negative 3 is the lesser factor of the two. So the solution here will be x is greater than 1 over 3, or x will be less than minus 3. In other words, the function increases from anywhere x greater than 1 over 3. However, increases again when x is less than negative 3. So we are told that it is further given that ax cubed plus bx squared plus cx plus d, and we are given that f of 0 is minus 18. Now this is obviously the y-intercept. So this is already the value d. This is going to be the value of d from this function. That's negative 18 right there. So I already know that my function looks something like that. Cx minus 18. Alright. Now again, initially I knew that my stationary points were at x is 1 over 3 and also at negative 3. So there's actually multiple methods of working this out, but I'm going to resort to deriving. So I'm just going to find the first derivative there. And just substitute these two values. And I could do the same for negative 3. I'll just substitute into that function there, or equation rather. I'll just stop at that again. Now what I do know is that these two are actually equal because they're both equal to 0. They're both my stationary points. So what I could do is equate them, see how far that takes me. Now already I can tell that these two will cancel out, leaving us with Let's see. It's going to be 1/3 A minus 27A being the like terms plus 2/3 B plus 6B, equating these to 0. What do we get here? What do we get here? Go ahead and punch these into your calculator. So we got 103 minus 27. Whoa, and that's minus 80. A divided by 3. And what do we get for, my bad, and what do we get for 2/3 plus 6? We got 20 B over 3. Now of course this can be, the denominators could be ignored, so that will leave us with minus 80 A equals minus 20B. Of course, let's just divide by the lesser factor, in this case being negative 20. So if I divide both sides by negative 20, I will get a positive 4. So another B is 4. What about the other points? Well, I already used the first derivative to get to B. The other thing that I know is my second derivative was given as 6x plus 8. And the other thing that I know about my second derivative is that at the point of inflection, that's got to be equal to 0. So 6x plus 8 equal to 0 becomes 6x equals minus 8. That's just simply 8 minus 4 over 3. Now when I do that information is, I now know initially that if I am to find the second derivative of a given function, which will be 3ax squared plus 2bx plus c, the second derivative of this is 6ax plus 2b. And also another, again, my second derivative slash point of inflection is 0. Rather, point of inflection happens to have the second derivative equated to 0. So I can just work that out there, because I know now that this point of inflection has x value minus 4 over 3. So I can work with it. So that's 6a into minus 4 over 3 plus 2b equals 0. But as we all know, that's going to be minus 24a over 3. We found, remember, b to be 4. And from here it's just mathematics. So I have minus 24a divided by 3, that's equal to minus 8. If I cross multiply, I'm going to have minus 24a equals minus 24. So of course if I multiply both sides by negative 24, my a is a positive 1. So now to find the last point, which is c, I could just substitute into that. So I already know that one of my x values of the turning point will be at negative 3. So I can just substitute. So 3a is 1 and x is minus 3. I would square that. 2b is 4 and x is still negative 3. And that's for me to find c right there. Now I know that my first derivative at negative 3 is 0, so I can just simplify the whole thing. So that's going to be 3 times 9, which is 27, and that's going to be minus 24 plus c. That's going to give us a difference of 3, meaning c is negative 3. So in conclusion, we got all our values. we got A being 1, B being 4, C being -3, and of course D was given right from the start, which was at -18.